Hello, welcome to the Egg Network. My name is Shelton. Today, we're going to be talking about eggs. Now, most of you know what an egg is, but in case you've been living under a rock, I'm here to explain. This is an egg. Eggs are a round capsule that baby animals can grow in and hatch out of. However, some unfertilized eggs are edible, like chicken eggs, which is this one. And that is the subject of today. So now that we're all familiar with what an egg is, let's find out what it's made of. The eggshell here is made out of calcium carbonate, or CaCO3. The inside of the egg is made of mostly protein, water, and fats. There are two main parts, the egg white, which is called albumin, and the egg yolk. The egg whites are made of 90% water and 10% proteins, no fat. The part of the egg white that makes it gloopy and slimy like this is called ovomucin. And then in the egg yolk, there is more protein than the egg whites, but also more fat and cholesterol. And egg yolks are where most of the vitamins and minerals are, such as iron, phosphorus, calcium, thiamine, riboflavin, and vitamin A. Okay, now I know how appetizing this slimy mess looks, but you can't just eat it raw. Raw eggs are generally deemed unsafe for consumption because of bacteria that could be in the egg called salmonella. Refrigerating eggs helps prevent the growth of this bacteria and prolongs shelf life and quality. Pasteurized eggs are heated enough at the right temperature, around 140 degrees Fahrenheit, to kill most of the salmonella in the egg, but they still aren't completely safe to eat raw. The best way to ensure all the salmonella in the egg is killed is to cook it. But how does cooking an egg change it? As you should already know, when you cook an egg, it changes from this gloopy, slimy liquid to a less goopy, more solid, rubbery texture. But why does this happen? Well, proteins are long chains of amino acids, and before you cook an egg, the long protein molecules in the egg are individually coiled up. But when the egg heats up, the kinetic energy of the proteins increases, and with enough energy, it can overcome the hydrogen bonding that keeps the proteins coiled up. Then they begin to change shape and denature, and those unfolded proteins bond with one another and create a 3D network in the egg that holds small pockets of water, and that is what makes it solidify. The more intense the heat is, the stronger the bonds between the proteins will be, which makes for a firmer egg. Wait. What's that smell? It's hydrogen sulfide! As the sulfur in some of the proteins in the egg whites reacts to the heat of cooking, hydrogen sulfide is produced, which gives off that egg smell. But you should be careful not to overcook the eggs. Overcooking eggs, such as boiling an egg for too long, can produce too much hydrogen sulfide, and that could make it dangerous to eat because H2S is a toxic gas. Speaking of boiling eggs, that's the first method of cooking eggs that we're going to be talking about. It's my personal favorite because you really don't have to do very much. You just put some eggs into a pot with water, wait for the water to boil, then turn off the heat. Then you cover the pot with a lid and let the eggs sit for around 6 to 10 minutes. And then you put them in an ice bath. This exposes the egg to a lot of heat all at once, which is why hard-boiled eggs are firm and rubbery. The extreme heat makes the proteins have stronger bonds and makes them have more bonds with each other. But don't be confused. Boiling eggs doesn't mean you boil the stuff inside of the egg. The hot water just transfers heat to the egg, which provides it enough energy for the proteins to denature and coagulate. And the more they coagulate, the more rubbery the egg will be. Oh yeah, now we got a boiled egg. Time to crack this thing open to see how rubbery it is. And there we go. We've got our boiled egg. Whew. I can definitely smell that hydrogen sulfide. It's very eggy. All right. Now let's cut into it to see what the middle looks like. Oh yeah, look at that. It's a perfectly boiled egg. Now if you let the eggs sit in the hot water for longer, then they will become more rubbery because you're exposing them to more heat, thus cooking the proteins even further. But if you expose it to less heat, then they'll be more watery and gooey. Delicious. Another method of cooking eggs is called poaching. Poaching an egg is when you crack an egg into hot water. It's very similar to boiled eggs, but is usually done in less time, resulting in a softer egg. Simple as that, right? Wrong! There are so many aspects to think about when it comes to poaching an egg, such as the time that it takes to cook it, and the temperature of the water, and the egg whites spreading throughout the water. And as you should already know, the hotter the water and the longer you cook it, the firmer the egg will be. But poaching an egg for a longer time reveals another problem: the egg whites dissipating into the water. You don't want the egg whites to dissipate because then they'll spread out throughout the water and it'll be harder to eat. You want the egg whites to stay in one clump with the rest of the egg. One way to combat this problem is to add vinegar to the water. This works because vinegar is acidic, and acids can denature proteins. So, using vinegar in the water will make the cooking process happen faster, since the proteins are being denatured by both heat and the acid. So the egg whites have less time to spread out in the water. Next up, we have fried eggs. They're very tasty, but also pretty hard for me to get right. You have to heat up a pan of oil to the right temperature, and then crack an egg into it without breaking the yolk, and cook it for the right amount of time. The temperature and time that you cook it can drastically change the outcome, which is why you have to get it just right. The basics of it are the same as any method of cooking an egg, but what makes it unique is that the egg is spread out on a flat pan. Here, you can see the bottom of the egg turning white, which means it's cooked. But there's also still some translucent parts on top that haven't been cooked. Compared to boiling or poaching, a fried egg is placed on a flat, hot surface, meaning the bottom of the egg is heating up much faster than any other part of it. In this side-by-side, the left egg is being cooked on low heat, and the right egg is being cooked on high heat. When the egg is first cracked into the oil, the egg on the right immediately turns white, but the egg on the left doesn't become opaque as quickly as the other egg. This is because if you fry eggs slowly at a low temperature, you will get a soft egg that is evenly cooked because all the proteins in the egg will have time to be exposed to the same amount of heat. But frying eggs at a high temperature will make some parts of the egg firmer than others because the edges and the bottom will cook much faster than the middle. Here on the left, you can see that I'm pouring the hot oil on top of the egg. This is called basting, and it cooks the top part of the egg and helps get a better cooked egg. And here, you can see that the top that was once translucent has now become white.
Yeah, it's cooked. It's really hot, so it's cooked.
And when we flip the eggs over, you can see the bottom of the right egg is much more cooked than the bottom of the left egg. Here's the egg that was cooked on low heat. Isn't it just the perfect fried egg? It's got nice tender whites, and the yolk in the middle isn't too runny and isn't too firm either. Cooking it low and slow really is the best way. But if you're scared of a runny yolk, you can make scrambled eggs. Scrambling eggs is essentially the same as frying an egg, except you mix the egg white and egg yolk together, and when you put it in the pan, you mix it around. Since the yolk has a different composition than the egg whites, it reacts differently with heat and oil. This means the time and temperature for scrambling eggs is different than frying them. Mixing the yolk and egg whites together also allows the scrambled eggs to absorb more oil than frying an egg. But with a bit of practice, you can get the perfectly fluffy scrambled eggs. And now, a word from our sponsor. Do you have an enemy? Do you need to get revenge? Is there someone you would think the world would be better off without? Buy a microwaved egg. With a microwaved egg, you can make an egg bomb that explodes in anybody's face. When a boiled egg is put in the microwave, the water inside the egg heats up. And with the state-of-the-art technology, the egg yolk can get even hotter than 212 degrees Fahrenheit.
That's hotter than boiling water.
That's right, but it won't explode in the microwave. The superheated water in the egg stays at a high pressure inside the egg until you break it. That means, as soon as your victim bites the egg, all the pockets of water expand, making the egg explode in your victim's face. But does this explosion really do any damage? Of course! The sound of the explosion can get as loud as 133 decibels, only 30 decibels away from the sound of a gunshot. And it really is effective. We've had so many reports of hearing and vision loss. So buy a microwaved egg today to get annoying people out of your way.
Now back to your regular programming.
Hello, my name is Egg Sheeran. Your previous host accidentally ate a microwaved egg. I wonder how that happened, and can no longer run the show. Fortunately, I'm here to take over from now on. So let's start with the baking segment. To start off, eggs are very useful in baking. They're made of fat, protein, and water, which gives them many purposes. They can act as a leavening agent, emulsifier, they add structure, and they keep the food moist. Whole eggs are a good leavening agent and help baked goods rise. The proteins in the egg coagulate and firm up when they're cooked, giving structure to the food. This is also why adding too much egg into a mixture can lead to a dense result. I have 2 cakes here. This cake, which is where this slice comes from, has the correct amount of eggs. And this cake, which is where this slice came from, has 1 extra egg. As you can see, this one is more fluffy, while this one is more dense and rubbery. And in this one, when you cut it open, you can see that the air bubbles are bigger than the air bubbles here. These ones are small and compact, which means that it's dense. And that's because I put too many eggs in it. And this one here is nice and fluffy. They have big air bubbles that aren't too big and aren't too small. That's because it has the correct amount of eggs. Egg yolks and egg whites both contain the phospholipid lecithin, which acts as an emulsifier because the molecule has a hydrophobic and a hydrophilic part. Even though oil and water don't usually mix, lecithin helps them combine because oils will be attracted to one part of the molecule and water will be attracted to the other part. Eggs also help with moisture as they contain a lot of water, and the network structure that the proteins create can trap water, which adds even more moisture. However, egg whites and egg yolks have different compositions, which affects how they act in baking. Both parts have water and protein, but the yolk also has fat and more nutrients. Usually, egg whites are used to give food more volume. This is because when you whisk egg whites, since there's no fat, air is incorporated and the proteins uncurl. This increases the volume of the egg whites.
1 eternity later.
Some foods that only contain egg whites are pavlova, macarons, buttercream, angel food cake, and meringue. Egg yolks, since they have fat, also contribute to the taste, but egg whites, which don't have any fat, are pretty much tasteless. Now, if you feel like cooking with eggs at home, you have to make sure it's not rotten. One way to tell a fresh egg from a rotten egg is to put it in water. A fresh egg should sink in water because the density of the egg is higher than the density of water. But a rotten egg should float because as the egg ages, the whites inside the egg decompose and release a gas. But it's not the gas that makes the egg float. It's because the eggshell is semi-permeable and that gas escapes. And since the volume of the egg stays the same, but the mass decreases, the density also decreases. And once enough gas has been released, the egg will start to float in water because the density of the egg is now lower than the density of water. But refrigerating eggs can help slow down the decomposition process, which is why it's always best to refrigerate your eggs. When an egg is laid, the egg whites have a pH of around 7.6. And as I said before, the egg releases gas as it ages. One of those gases is carbon dioxide, or CO2. CO2 acts as a weak acid inside the egg, so as it escapes out, the pH of the egg whites increases to about 9.2, making it more basic. One way humans have figured out how to preserve eggs is by making century eggs. Century eggs are duck or chicken eggs that have been preserved with alkaline fermentation. These eggs are dark in color and smell terrible. That gross smell actually comes from ammonia, NH3, and hydrogen sulfide, H2S. Traditionally, these eggs are prepared by covering eggs in a paste made from calcium oxide, sea salt, tea, and wood ash, then leaving them to sit for many months so that the paste hardens. Back then, people didn't know why this method worked, but now, with our more advanced science, we know what chemical reactions happen inside the egg. The reaction needs sodium and hydroxide ions, Na plus and OH minus. Since we do know what happens, the method of making these eggs is different now. Modern methods include soaking eggs in a mixture of calcium hydroxide, sodium carbonate, and salt for 10 days, and then allowing them to age in an airtight container. One of the main reactions that occurs in the egg is as follows. Sodium carbonate and calcium oxide and water react to produce 2 sodium hydroxide and calcium carbonate, shown in this equation. The NaOH diffuses throughout the egg and raises the pH to as high as 12, and, like acids, bases such as NaOH also denature the proteins in the egg. In the century egg, they coagulate and turn the egg white into a dark gel. Fermentation can preserve the eggs by limiting the growth of bad bacteria in them, and although they are safe to eat, they don't look very appetizing, and they smell really bad. But I do know some people who enjoy eating them, even though they're like dark and black and gooey and just like, ugh, disgusting. But I mean, hey, you do you.
Behind the scenes. So, can you tell us why you decided to make an egg network, specifically about only eggs? Oh, well, that's easy. I like eggs. And also, I like cooking, it's pretty fun. But also, I like it when my dad cooks, because that means I don't have to cook? So, why did you decide to call it the Egg Network? Oh, that's easy. That's because it's an egg network. It's a network on TV about eggs. And also, I talk about how when the proteins in an egg denature, they create a network that can trap water. So it's kind of a pun. If you listen closely to what I say, you would understand. Oh, I wasn't really listening in that part. I had to go to the bathroom. Yeah, sure. Okay. Anyways, next question. So, what exactly happened to the previous toast, Shelton? Oh, that was just a, minor accident. The microwaved egg had absolutely nothing to do with me. Nothing at all. I was not involved in that whatsoever. Okay, I think we're done here. Bye. Bloopers.
Eggs are round, and they're a little capsule for animal. Blah. And a state-of-the-art. So, how yours is? Usually, when you use when you use only egg whites, it's used to give food. This is gonna take a while. This would be so much easier with an electric mixer. I'm not a robot. I'm not a machine. I can't do that. You can already see the bubbles. This is supposed to become cloudy. This is not cloudy yet. I read it's gonna take like 10 minutes. Jesus Christ, I can't record all of this. I can't even do this. My arm is already getting tired. Okay.
I'll do it. Why would you do that? Zip it. No.
This cake on the right side. Okay.
Can I have it?
No.
Oh.
Well, not yet.
Can I just small piece? I want the one have more egg.
Why?
I don't know.
It's not as good. It'll be chewy.
I like it chewy.
Okay. The egg yolk can get even hotter than one.
Look, I'm coming.
Okay, so I'm about to microwave this egg. We'll see how this goes. Express. Ooh. Egg. Oh. Oh, Jesus Christ. Oh, frick. I'm really scared right now. Look at the egg. That doesn't look safe at all. I think I might die. My research said that this is not safe. Okay, so we are outside now, and I'm going to touch it with the end of this pan. Really, really carefully. I think it's fine. Okay, cool. I am safe. I heard popping. That was scary.